So we'll finish up the notes on 3A with this last percent problem formula, as well as common abuses of percentages on the last page. The formula that you see here down towards the bottom, it says original amount plus or minus percent times the original amount equals your total amount. You'll know when to use addition and subtraction. You'll use addition whenever you are paying tax on an item, you experience a price increase, a salary increase, commission type problems. Real estate agents, car salesmen, for example, work on commission, so that would be an additional part of their income. You would use subtraction for discounts or a decrease in some amount. It might be a salary decrease or a decrease in your some bill or something like that. Okay, so it hopefully is very straightforward about which to use. So we'll look here at example 13. It says you go to Walmart and buy a video game with a sticker price of $38.15. Of course, North Carolina sales tax is 7%. We want to figure out then what's the total amount then you have to pay the cashier for the items that you buy. So since this is a case where I'm buying something and then I'm paying tax on it, I'm going to use my addition sign. So my formula would be the original amount plus percent times that original amount equals my total. So the original amount here, $38.15 plus a 7% sales tax, so 0.07, times $38.15. And essentially, you can just type that in your calculator from left to right, and that's going to give you your final answer. Your out-the-door price for this video game then is going to be $40.82. Okay? I'll let you try example 14. It is a discount, so be sure you note that you'd be using subtraction there. Okay, we'll flip it on over then to our last page. I definitely want to look at example 15 because it is a little different in the what you'll be solving for here. So it says the rate of smoking among 8th graders was up 44% to 10.4%. And they want to figure out, well, what was the previous rate for 8th graders? So since we're experiencing a percentage increase, I'm going to use my addition sign. So I'm going to go to my formula, original plus percent times original equals my total. The original number of 8th graders who smoked, I don't know, so I'm going to have to put an X there. But I do know that represents it's up 44%. So I'm going to put in my percent spot, I'm going to put 0.44. Or again, original amount I don't know, so an X there, equals the total amount, 10.4%. Okay, that 10.4% there, I don't need to change it to a decimal because I'm not putting it. Percents need to be changed to a decimal. Using it in the formula. So this is a percent being changed to a decimal. But here, this is a total amount, and the total amount is a percentage, so that doesn't need to be changed. So now, if I add these together, in front of that X sitting up here by itself, there's an imaginary 1 sitting in front of that. So this is like 1 plus 0.44, or like $1 plus 44 cents. So now adding those two together, you have 1.44x equals 10.4. Last step, you want to get x all by itself. Always divide by the number beside your letter. So divide by 1.44. Whatever you do to one side, do to the other. Cancels out over here, just leaves you with x. So x equals 7.22%. So the original number of 8th graders who smoke then was 7.22%. Okay. And then we'll conclude this section with common abuses of percentages. And I'll try to go through these. In example 16, it says that because of losses, your boss says that he must cut your pay by 10%. However, he says, I'm going to promise you in 6 months, I'm going to give you a 10% pay raise. And our question is, well, if he does that, if he cuts you by 10% and then gives you an increase by a 10%, is he going to restore your pay back to your original salary? Some of you might off the bat already know, hey, that's not going to work, but others of you might say, okay, I need some concrete numbers here to work with. In that case, just make an easy base salary for yourself. So let's just say our base salary was $40,000. And again, I'm just making that number up. So base salary is $40,000. All right, and let's say, okay, we get the cut. And so if you're getting that pay cut, then you're taking that $40,000, subtracting 10% of $40,000. That's going to put you at a new salary of $36,000. So that is your pay after you've had the pay cut, your 10% pay cut. So then he says, okay, well, now I'm going to promise you to give you the raise. So after the raise, he's going to give you a 10% raise on this amount. So now you might be seeing, oh, now I see where this is going. That if I take that $36,000 and I get a 10% raise, so I'm adding of that $36,000. There's no way I'm going to be able to restore back there, but if you pop it in your calculator, you're going to see, you're going to get close, but you're not going to quite be where you originally started. You're going to be at $39,600. The reason for this is because you've got a shifting reference value. You know, you went from a base salary of $40,000, and then once you did that 10% pay cut, he was now, instead of that $40,000 being your reference value, now you've got a new reference value here of $36,000. In example 17, a lot of times this is something that even myself, I've been guilty of. I'll say, oh, I'm 120% sure that, this is the way something is. But, in all actuality, the only time that we should be using a percentage over 100% is whenever we are talking about a change or comparison of some sort. So, for example, here when we say a store advertises that it will take 150% off the price of an item in the store, what would happen then if you got to the counter and was going to buy a $500 item? So we're going to buy this $500 item. It's going to get a discount, so we're going to subtract 150%, change that to a decimal, so we're talking about 1.5, multiply it times the price of the item. If you do that, like I said before, you can just type that directly in your calculator. You should get negative 250. So essentially then, what we're saying is, oh, that store owes you $250. It's definitely not going to happen. Like I was saying, the only time that your percentages can exceed 100% is whenever you're talking about a change or a comparison. A good example of that is you could say, well, I get 150% more miles to the gallon than your car. Okay, so you can compare cars. There's some, as long as you're doing some kind of comparison, my car runs 120% better than your car, things like that. It doesn't always have to be cars, of course. That's just what's coming to my mind at the moment here. All right. Lastly, here in example 18, it says 70% of the boys and 60% of the girls in a class voted to go to the water park. Is it then logical for us to conclude that 65% of the students in the class wanted to go to the water park? In general, we really should never be averaging percentages. I'll give you some math, though, to sort of show you behind the scenes. So let's say, for example, you've got 20 boys in the class, and we've got 80 girls. Total, then, we're talking about 100 students. Then it said in the problem that 70% of the boys wanted to go. So 20 boys times 0.70, that's a 0.70. That's going to give me 14 boys that wanted to go to the park. My girls, 60% wanted to go, so I'm going to take that 80 and multiply it times 0.60. 80 times 0.60 is going to give me 48 girls. If I add those two together, then I'm talking about 62 total students that wanted to go to the water park. So as long as we came over here and you got 100 students and you find out that 62 of them want to go to the water park, then you'd be in good shape. But we know that 65% wanted to go. So multiply that times 100 times 0.65, and of course that's going to be 65 total students. And so what they were trying to do in this problem is say, okay, well, 70% plus 60%, add those two together and divide by 2, that's 65%. And that never works as far as averaging those percentages. You can see you're somewhat close, but you're still off. So you should never, as a general rule, average percentages. I'll let you then work through example 19 to see whether those are being used correctly or incorrectly. And of course, the solutions are posted to Blackboard. Thanks.